Hello there everyone, and welcome to today's video on active transport. So active transport is the opposite of passive transport. Now passive, remember, didn't require energy, so simply put, active transport is going to be the transfer of molecules with energy. For example, we're going to be discussing endocytosis and exocytosis. Now the way I want you to think of this is like a salmon going upstream. You can go ahead and swim against the current, but it's going to require energy to do it. Let's get started. So active transport is the movement of molecules across the cell membrane that requires energy. So in this case, it can actually move materials from an area of low concentration to an area of high concentration. So this is the opposite of diffusion. So, considering what we know with diffusion, which is the movement of molecules from a high to low concentration, active transport is the opposite. So if this same example went ahead and was carried out by active transport, we could actually go ahead and move not from A to B, but we could go from B to A, going from an area of low concentration to an area of high concentration. However, it requires energy to do so because we're going against the flow. The first example of this that we're going to discuss is called endocytosis. So endocytosis is when large molecules can be engulfed by the cell. So we're bringing in larger molecules across the cell membrane against the current. So as we can see here, we have our cell membrane, we have an influx of material going ahead and coming in, and it continues to go ahead and push on the cell membrane until part of the cell membrane actually pinches off and becomes a vesicle, where it's then gone ahead and transported to wherever it needs to be inside the cell. Now regarding endocytosis, we actually have two different types. The first type is pinocytosis. So pinocytosis is bringing a liquid inside the cell. So consider it cell drinking. Whereas phagocytosis is bringing in a solid. So think of it like the cell is eating. So pinocytosis, cell drinking, bringing in a liquid. Phagocytosis, bringing in a solid or cell eating. The final example of active transport we're going to be discussing today is exocytosis. So exocytosis is when large molecules are being released by the cell. So in this case, it's kind of the opposite of endocytosis. So we have our vesicle, which goes ahead and works its way up into the cell membrane. Now considering that the vesicle and the cell membrane are both made of phospholipids, the vesicle will actually go ahead and merge with the cell membrane. And once it merges with the cell membrane, it opens up, going ahead and releasing whatever products were inside out into the extracellular fluid to basically be dispersed as they see fit. So that right there covers active transport. A little bit shorter and more concise than passive transport, but you get the point. So remember, active transport is going upstream, going against the current. So you need energy to go ahead and carry it out. That's going to go ahead and close up shop today on active transport. Thank you very much for your time, and if you have any questions, please feel free to go ahead and contact your instructor. They'll point you in the right direction. Now that that's said and done, until the next video, take care of yourselves, and I'll see you next time.